Welcome to day 15. Our goal today, given a word problem with inequalities, you will be able to set up an inequality equation and solve. All right, so let's go ahead and take a look. So first off, your notes say 14, change that to 15. All right, so these are inequality word problems. Remember, with our word problems, the first thing we're going to do, put our pencil down, and you're going to read the entire question first and think, what is the main idea? What am I trying to find? After you do that, you can reread the question and start circling or underlining important information that can help you set up an equation to solve. All right, so let's take a look here at number 1. At Darien Lake, in order to ride the Superman, you must be no smaller than 51 inches, but less than 80 inches. Represent the situation in the form of a compound inequality. Okay, so what's our main idea here? Okay, well, all we want to do is write a compound inequality. So we're really not setting up an equation, we're setting up a compound inequality, which remember has your x in the middle, and then has an inequality symbol on either side. So let's reread the problem now and see if we can find the information we need. At Darien Lake, in order to ride the Superman, you must be no smaller than 51 inches, okay, but less than 80 inches. Okay, so let's take a look at the first part. No smaller than 51 inches. So are you allowed to be 51 inches? Yes, you just can't be smaller. So that means x has to be greater than or equal to 51. Now it says you have to be less than 80 inches. That means, are you allowed to be equal to 80 inches? Nope, you have to be less than 80. So this would be less than 80. And at this point, we have now written our compound inequality. Okay, let's take a look at question 2. So put our pencils down. Connor wants to attend the town carnival. The price of admission to the carnival is $4.50 and each ride costs an additional 79 cents. If he can spend at most $16 at the carnival, which inequality can be used to solve for R, the number of rides Connor can go on, and what is the maximum number of rides that he can go on? Okay, so the main idea here is we want to find how many rides he can go on, which means we want to find, so the number of rides, which is we know is going to be R. So we're going to say let R equal the number of rides. Okay, now let's reread and underline important information that will help us set up an equation. The price of admission is $4.50, so admission is $4.50, and each ride is an additional 79 cents. He can spend at most $16. Okay, so there's 3 main ideas there. Admission to the carnival is $4.50. So does he have to spend $4.50 over and over and over again, or is he spending $4.50 once? That's right, he's only spending it once. So that's going to be $4.50. Then it says each ride costs an additional 79 cents. Remember, R is the number of rides. So that's the cost that's going to happen over and over again. So 79 is going to be multiplied to our R. He can spend at most $16. Now, does that mean he can spend more than 16 or less than 16? That's right, he has to spend less than or equal to $16. So at most, that means he must have $16. Okay, so first things first, let's go ahead and see if we can take away any of our options here. $4.50 plus 0.79R, that's this one and this one. So we can cross off 1 and 2. So now let's see, is it going to be 14 rides or 15 rides? So in order to figure this out, we're going to have to solve. So let's go ahead and subtract $4.50. So we get 0.79R is less than or equal to We have 1150. Divide by 0.79. And R has to be less than or equal to 14.55. Okay, now R is less than or equal to 14.55. That means, can R be 15? No, because 15 is going to be greater than 14.55. So you actually have to round down here because R is less than or equal to. So in other words, another way you could do this is we could set up a number line. So 14, 15, and let's go ahead. 14.55 would be about here, and you would have to shade this way. So 15 would not be in the solution, so it would have to be 13. We've got it. Okay, next up. So again, pencil down, let's read the question. Lisa brought half of her savings to the bakery and bought 12 croissants at $14.20. The amount of money she brings home with her is more than $2. Use an inequality to find how much money she had in her savings before going to the bakery. Write the inequalities that represent the situation and solve it. Okay, so let's think, what's the main idea? Well, the main idea is we want to find out how much money she has in her savings before she goes. So I'm going to say let X equal the money in savings. Okay, so now that we have that, we know the main idea, we're going to find how much money she has in savings. Let's go back up. Lisa brought half of her savings. Now that's important. She brought half of it with her to the bakery, and she bought 12 croissants for $14.20. Okay, so for $14.20 is how much she spent. We don't know the cost of each croissant, but we know all together they equaled $14.20. So 12 croissants is the same thing as the $14.20 there. The amount of money she brings home with her is more than $2. Okay, now let's see if we can figure this out. So she brought half her savings. Well, if X is the money in savings, she brought 1/2 of it, okay, to the bakery. And she bought $14.20. Now, if she bought, is that going to increase her savings or decrease her savings? It's going to decrease, so that's minus $14.20. Okay, and she brings home with her is more than $2. So here's the word is, so that's going to be like the equal sign, but in this case it's an inequality. So she brings home with her is more than $2. So this has to be more than $2. Okay, so now that we have our equation, we can solve for X. So the first thing I'm going to do is I'm going to add $14.20 to each side. So I'm going to get 1/2 X has to be greater than $16.20. And then I'm going to multiply each side by 2/1. So those cancel. And we get X is greater than $32.40. So how much money did she have in her savings before going to the bakery? Well, she had at least $32.40. And you have now solved the equation. Okay, let's flip it over now and let's try just one more question here. So here we have Caden and Riker washed cars to make some extra money. At the beginning of this year, Caden had already washed 24 cars. He continues to wash cars and washes 15 cars each month for the year. Riker is new to the car washing business, so he only had 12 cars at the start of the year. Riker is able to work more quickly, so he can wash 20 cars each month for a year, or for the year. So A, Write an inequality that could be used to model the situation showing when Riker would have washed more cars than Caden. And B, during what month during the year will Riker have washed more cars than Caden? So let's think. What's the key idea here? Well, the key idea here, what we're trying to figure out is what month, okay, Riker's going to have more than Caden. So that means we're going to say, let X equal the number of months. Okay, so we're trying to find the number of months. That's the main idea. That's what's missing in this problem, is how many months. Now, there's also another key idea here, and that is we want to know when Riker is going to have more than Caden. So in this question, we're trying to compare two different people. So what I'm going to do to set up my equation is I'm going to say, well, I want to know when is Riker going to have washed more cars, so more than Caden. Okay, and that's what we want to do here. We're going to set up two expressions and put them in the inequality to find out how many months. So let's go back now and let's highlight or underline some information. So at the beginning of this year, so here's Caden. So maybe I'll highlight here and I'm going to find Caden. So Caden had already washed 24 cars, and he washes 15 cars each month for a year. Okay, so that means Caden, we're going to go underneath Caden now. He's already washed 24 cars, so that's the constant, 24. And he washes 15 cars each month, and we know X is the number of months. So plus 15X. Now let's read for Riker. So Riker is new to the car washing business, so he has only washed, so this is Riker, he has only washed 12 cars, but he is able to work more quickly and he can do 20 cars each month for the year. So let's take a look. So I'm going to put my inequality symbol there. So Riker, he starts with 12, so that's your constant, and he can wash 20 per month, so that's 20X. Okay, part A, all it wanted you to do was write the inequality. So now for part B, let's go ahead. During what month will Riker have washed more cars than Caden? So let's go ahead. So 12 plus 20X is greater than 24 plus 15X. Let's solve. So we're going to subtract 15X. So 12 plus 5X is greater than 24. Then we're going to subtract 12. So 5X has to be greater than 12. Divide by 5. Okay, and then X has to be greater than, so let's go ahead, we're going to divide it out. So 12 divided by 5, and we get 2.4. Now, read carefully. So during what month during the year will Riker have washed more cars than Caden? Well, X has to be greater than 2.4. All right, so that means, are we going to have to round up or are we going to have to round down? If X has to be greater than 2.4, yep, that means it would be the third month. Okay, it's the third month. Now let's go back. It says during what month? Now here it says they started at the beginning, up here, at the beginning of this year. So let's think, what's the third month going to be? You got it. It's March. All right, ladies and gentlemen, great job today. I'll see you in class tomorrow.